right. Let's see. Today we have Algebra 2 lecture for 1020 and 1021. That's OSA 2811 again. The student will solve quadratic equations by factoring. This time we're going to factor in where the very first term is not a 1, as we've done in the past, but we're going to be doing it within the context of equations. So what I want to do is set the equation equal to 0, factor, employ the zero product property, and solve. That's going to be what we're doing. It's very similar to what we've done in the past, except our coefficient for the quadratic term is not going to be a 1, and we're going to have to handle that. Okie dokie, so here we go. We're going to try to solve this. I'm going to add 77x and add 196 to both sides. That turns this to 0. And on the left side leaves me with 7x squared plus 77x plus 196. That's all on the left side of this equal sign now. So here's the equal sign, and this turns into just a 0. 77 minus 77x, 77x minus 77x is 0, 196 minus 196 is 0. So now I'm going to factor this side and employ the zero product property. The first thing I see is that this is a 7, so I'm going to see if all of these will divide by 7, and I think they will. I know this will. 7 goes into 19 twice, so yeah, that would, I believe that will. So I'm going to call this 7 times the quantity x squared plus 11x plus, that'll go in twice with a remainder of 5, so it'll be 8 equals 0. And I'm going to check that with my calculator just to make sure I've got that factored correctly. I factored a 7 out of each one of these terms. I wrote 7 down and then divided each one of these by 7. And my check will be to multiply these and make sure I get this, which is what I'm doing right here. These I can do in my head. 7 times 28, just to make sure I haven't messed up. 196, yay. Now I'm going to factor this quadratic trinomial. This will give me 7. And I'll put the square root of this one here and here. I look for factors of 28 that will add up to 11. That would be 7 and 4. It doesn't matter where I put them. What matters is that they add up to positive 11. I could put the 4 here and the 7 here. That's fine. They have to add up to positive 11, and the only way that can happen is if they're both positive. Now I've gotten this factored, so I employ the zero product property. If this times this times this is 0, then either this is 0, and it never will be, it's just a 7. There's no variable in it. So 7 is a constant, it will never equal 0. But this could equal 0 if x is negative 7, and this could equal 0 if x is negative 4. So I'm going to make those two statements. X plus 7 could be 0, or x plus 4 could be 0. If I'm multiplying these two things together and getting 0, one of these has to be 0. Here, subtract 7 from both sides, x would equal negative 7. Subtracting 4 from both sides would yield x is equal to negative 4. This would be our solution. And oftentimes, they are written in set notation. And the order in which the solutions are written doesn't matter. You can put the negative 4 first and the negative 7 second, it doesn't matter. This doesn't matter either. This is not an ordered pair. It's just a set of members. Okay, so let me scooch these over if I can. Give myself room to work over here. There we go. All right. So hopefully that made sense. I'm going to do another one here. I'm going to add 96n to both sides and add 288 to both sides. And this time, instead of showing it like this, I'm just going to do it in my head. If I add 96 to both sides and add 288 to both sides, on the left side I'll wind up with 8n squared plus 96n plus 288 equals, and on this side I'll have a 0. Because I added 96n here and I added 288 here, that turned into 0. I added 96n here and 208n on this side, and the left side looks like this. Okay, that's just a little bit quicker. You can do it this way if you want though. I'm going to now try to factor out an 8. I'll see what the biggest thing is that each one of the biggest factor that each of these shares, and I think it's an 8. I'm going to give that a try. This will give me n squared plus 1, 2, 12n, and 8 goes into 24 6 times, I think, 36. And let me check that with my calculator just to make sure. I'm doing a check now, I'm distributing this. 8 times n squared is 8n squared. 8 times 12, I'm nearly certain, is 196. But it's early in the morning and my brain doesn't always work the greatest. 8 times 36, 8 times 36 equals 288. So yay, got it factored correctly that far. Now I'm going to try to factor this quadratic trinomial. Square root of this one here and here. Factors of 36 that add up to 12. Well, 2 and 18 won't work. 3 and 12 won't work. 4 and 9 won't work, but 6 and 6 will. 6 times 6 is 36. And 6 plus 6 is 12. And what matters is they have to add up to positive 12. So the only way that can happen is if they are both positive. And so what I've got here is 8 times n plus 6 quantity squared. Either this one is 0 or this one is 0. This can't be a 0 because it's not a variable term. That's a constant. This will always be 8. So it'll never be 0, but this could be 0 and so could this. And we can see we're going to get the same answer here. Either n plus 6 is 0 or n plus 6 is 0. In either one of these, when we set it equal to 0 and solve, we're going to get n is equal to negative 6. We'll get that twice, but you only have to list it once. If I did both of them and solved them both and got n is equal to negative 6 twice, when I went to list them, I would only have to list it once. And it's often just shown like this. You only have to write the answer once. I wrote it twice, but n equals negative 6 is true in either case. I mean, they're both correct. So you only have to state it once. I'm staggering through this. Yay. Anyhow, here's our answer. Or it could be written like this. All righty. Hopefully that makes sense. Let's look at another one. Here I have a quadratic equation. I want to set one side equal to 0, so I'm going to keep my quadratic term positive and subtract 24x from both sides. That will give me 4x squared minus 24x on the left and 0 on the right. Remember, I'm subtracting 24x here and I get the 0. I subtract 24x here, 4x squared minus 24x. I've subtracted 24x from both sides. Now I'm going to factor this. It's a binomial, it doesn't have 3 terms, so I'm going to see what I can pull out of both of these terms, and I see how they both divide by 4, and they both have an x. So I'm going to write down the factor that they both have in common, open a set of parentheses, and term by term, divide a 4x out of each term. So if I pull a 4 and an x out of this by division, I'm left with the other x. Minus, if I pull a 4 and an x out of this, I'm just left with 6. Because 4x times 6 is negative 24. So if I divide x by itself, I get 1, and 6 times 1 is 6. So let's do a quick check to make sure I've got it factored correctly. 4x times x is 4x squared. 4x times negative 6 is negative 24x. I pulled the 4 out of this and the x out of this. When you pull it out, you're dividing. X divided by x is 1, and 1 times 6 is 6. Now I'm going to use the zero product property. If this times this is 0, then either this one is 0, or this one is 0. This is a variable expression, so I'm just going to divide both sides by 4. X equals 0. 0 divided by anything is 0, except for 0. 0 divided by 0 is undefined. Well, 0 divided by anything else is 0. Here I'm going to add 6 to both sides. I'll go ahead and show it this time since I showed this. Those are our two solutions. And it doesn't matter which one I put first, and oftentimes they're written in set notation. Okay. It's up a little higher where you can see it. Hopefully that makes sense. We'll do one more. It's very similar to this one. It's a binomial, but it's going to be a little bit different. I look over here, I want to set one of these sides equal to 0, and I want my quadratic term to be positive. So I'm going to subtract 100 from both sides. I'm not going to show it this time, I'm just going to do it. 4x squared, I'm subtracting 100 from the left side. Here's the equal sign. I'm going to subtract 100 from this side and get 0. Okay? Now look up here and say, hey, they both have a factor of 4. So I'm going to factor that 4 out. That gives me x squared minus 25 is equal to 0. And I look at this and I say, well, that's a difference of squares. That's a difference of squares too. But they had a common factor of 4, so I pulled it out, and the remaining binomial is also a difference of squares. So I'm going to factor this using the difference of squares pattern. This is x squared minus 5 squared. So I open up 2 sets of parentheses. Take the square root of x squared, put it here and here. Take the square root of 25, which is 5, and put it here and here. That's the pattern. Square root of x squared is x. Square root of 25 is 5. Make one positive, one negative, and it's factored correctly. If I were to FOIL this, my middle terms, my x terms, the linear terms would cancel each other out, leaving me with x squared minus 25. Now I've got this times this times this is equal to 0, so one of these has to equal 0. This one can't because it's not a variable expression. That will always be 4, but this could be 0 and this could be 0 depending on the value of x. So I'm going to say, well, either x plus 5 is 0 or x minus 5 is 0. Solving this by subtracting 5 from both sides, x equals negative 5. Excuse me. Or adding 5 to both sides to solve this one, x equals positive 5. Those are our two solutions. Oftentimes you'll see them combined into one expression, one equation, x equals plus or minus 5. The symbol right here just means it's x equals positive 5 or negative 5. It's a plus sign over a minus sign. I want to clear that up a little bit. Plus or minus 5. There we go. And it's often written in set notation, 5, negative 5, or it could also be written like this. Set whose members are plus or minus 5. This, or this, or this, or this are all different. They're all different ways of saying the same thing. So there we are. I hope that made sense. Solving quadratic equations where the coefficient of the quadratic term is not a 1. Always check to see if you can factor something out. Then use your factoring techniques and the zero product property. Hope that made sense.